So obviously, you could turn it in sooner and get a few more points back. The later it is, the less points you get back. Okay. So the very first thing we're going to talk about is section 4.9, if nobody has any questions. Okay. So kind of let go of the test. I know this is difficult to do. Go of it a little bit. Let's focus on some new stuff. Hopefully this will help you make corrections. Oh yeah, did I finish this one? No. What was this? Yeah. So real quick, how did anybody do this one? How do you make m become just a function of a?
Oh, it's going to be just.
What do you do with this?
Just plug that back in.
Yeah, we know what b is. So it'll be 1/4 a times 1/4 a squared. Right? What problem does this relate to? The last one.
cylinder.
The one about the cylinder that's somehow growing. Right? It's an old 50s horror flick, the cylinder that ate New York. And then how do I do this? Well, what's 1/4 squared?
1/16.
1/16, and what's a squared? A squared. So then you get 1/64 a squared. And then you can take derivatives of that, right? So that's, a lot of you guys, on that last problem, you just totally ignored that I told you what the radius related to the height. And you started doing these derivatives, and you got extra terms that you didn't need, and you didn't know what to do. Very first thing you do is you use all the information you're given, right? So R is 1/4 h, plug that into the volume formula I gave you, and then that's the function that you attack, right? Okay, enough of that. Now let's let go of this aspect. All right. We sort of did section 4.9 a little bit on the way as we're doing derivatives, because it just kind of naturally makes sense to talk about if I can go one way, I need to be able to go the other. Let me give you some notation. Let's start off nice. The notation that we normally choose for doing an antiderivative of a function is capital letter. So if I do the antiderivative of f, it's big ass F. Right? So how do you think about this problem then as you think backwards? Where would this have come from? What would I have taken the derivative of to end up here? X squared. And do you understand, the better you know derivatives, the easier this is going to be, obviously, yes? Now, is this the most general answer? No. What else could have been there, even though nothing shows up here? What could have been here? Any constant, right? Don't just pick a constant, because it could have been any constant, so we put plus c. Plus c is going to be the bane of your existence in chapter 5 and 4.9. People always forget to put the plus c, and then they put it in places they shouldn't. So it's just going to be a thing. Now, what I want you, now listen. All right, little side note. If I told you I had a function that has a constant slope of 2, what kind of function is that? What's the only kind of function that has a constant slope? Linear. Can you draw exactly the function I'm talking about? Why not? So I know it would be like over 1 up 2, right? So I know it would be this. I just don't know where the shit it is. Yes? So the derivative tells me the shape of the function, but without more information, I don't know where that shape sits. I don't know where plus or minus on the y-axis it is, yes? Can somebody tell me what this would be? So what would I take the derivative of to end up with 2? Well, actually, I guess it would be this. 2x, yeah. Plus z. I love it. Because all I've told you is that f has a constant slope of 2. So it must be a linear function, but I don't know what the y-intercept is. Yeah, I like it. Okay. So let's look at a more interesting problem. And actually, let's do this. Let's do this. Recall given f of x equals x to the n. What was f prime? What was the formula for f prime? What's the process? Right? Right, you bring the thing down, it goes down by 1. So let me ask you this. Let's see if you guys can figure this out. Let's do another example. I want to figure out, given f of x equals x to the n, what is this, right? I want a general formula for this. What are you doing, Ed? Calm down. Yes? Wait, do you know it because you saw it, or do you know it? Okay, hold on. I want to build up to this point. Okay, and then I'll ask you, all right? So let's investigate this. You guys all understand what's happening right now? So it should make sense that derivatives of certain forms have a specific thing to do, just like here, right? Derivatives, if they're in a certain form, there's a specific thing they do. So there should be something similar for at least some antiderivatives, right? There should be a form that they all have to follow. Same way, same reason. So let's do a few more examples. So this one we did was easy. Because why was this easy? Because 2 is exactly what would have been up here, right? Oh, shit. So let me make it harder. What if it was 3x? And this is where people fall apart a little bit. Now, why wouldn't this be x cubed?
Because it's not x squared.
Because it's not a squared up there, right? So what must be the power on the original function I took a derivative of? Let's start there. Since this is x to the first, this must have been x to the second, right? Now, if I just put a 3 here, what should be here?
6.
And that's not 6, is it? All right, now think it. Now, I really want you guys with me. And again, this is the baby steps into this. If I take a derivative of this, wouldn't that 2 come down and multiply by whatever's here?
So it's 3 times.
Beautiful. It must have been 3 over 2. You guys see that? In fact, if I apply that same thought process here, wouldn't this have been 2x squared over 2? And that's why it was just x squared. And of course, what I put there? So what is the general rule here? This is neat. Let's do one more. What about if I had, what do you got, Jeff? There, right, something there. What if I had this? What would big ass F be? Big ass F. See, what do you start with? What do you know for sure must have been true? What?
X to the fifth.
You know it had to be x to the 5th. Now this one you can reason out. What must have been here, so then the 1 to the 5 comes down, you get 10. 2, which is 10 divided by 5, yes? Doesn't the number in front have to have been something divided by 5 to become it? So I end up dividing by 5 in this case, so I get 2x to the 5th. Let's see. How do you check your work?
To the derivative.
Take a derivative.
Yeah.
Which is easier than antiderivatives, so checking is actually easier than the first problem anyway. Now, let's go back. So what happens here? What must the power have been? N plus 1. And like we just said, you end up dividing by, what do you end up dividing by?
2.
The new, not 2. whatever the new power is. What's the new power? Oh, shit. And of course, we have to put, you don't have to underline it, just get it if you want. So let's see why this makes sense. Look. If this process is multiplied by the old power, take the old power down by 1, the opposite process should do all the opposite shit, right? Multiply old power down by 1. Old power up by 1, divide by the new power. They're exact opposites, yes? Which is beautiful. That's what inverse operations should be. All right, how you guys feeling so far? So any expression in variables that have x to a power will be easy. Let's see if you guys agree. For real. Here we go. What if I had, where am I at 4? Sure. Yeah, let's just make it gross. Do it. Yeah. Sorry. You know the rule. The rule doesn't give a shit if that's a fraction or whatever, right? What kind of controls everything in these types of forms is the new power, right? The new power controls everything. The new power shows up down there, yes? So what will the new power be?
9/7.
Say again?
9/7.
9/7. So when we're doing antiderivatives, the shortcut to figure out a fractional power is add the top to the bottom and put it back over the bottom. Shortcut. 2 plus 7 is 7. Is 9, divided by 7. And what do I have to divide by then? 9/7. Let me see, did anybody say, is everybody with me? That's exactly the rule we determined. Get the new power, divide by that new power. Now, of course, since I have fractions, what could I have done instead of wrote it like this? Couldn't I have, Jeff, couldn't I have written it like this? Yeah. Dividing by 9/7 is the same thing as multiplying by 7/9. So here I get 11. And again, you can check your work. If you multiply, if you bring the 9/7 down, 1/3, the 7's cancel, I get 1/3, x to the 2 7s. Big ass. And of course the plus e dies. Okay, I like it. How you guys feeling so far? I mean, this is, again, the better you are at derivatives, the easier this shit's going to be. All right. So let's talk trig. All right. Yeah. Trigonometry. So what if I had, we'll make it nature, f of x equals cosine x. What would big ass f be? I love it. Good. I like it. Right? Is that cool? Well, how did you come up with that? What did you think?
Well, I thought, what's the derivative?
Yeah, you thought backwards.
Like it's just-
What would have been there that I'd take a derivative to get here? Right? And that's exactly the thought process you want at first. What if I had, you go chat. Go with big ass f. Negative cosine, yes, right? Because if you started with cosine, derivative would be, derivative of cosine is negative sine, shit, so I must have started with negative cosine. You guys see that? What really sucks about antiderivatives is you have to think backwards, right? And it's a lot like learning stick and putting it into it. You can hear the gears grinding as you're trying to think backwards. It's gonna suck, it just is. You gotta get used to doing derivatives, you go one way, doing antiderivatives, you go the other way. So your gears are gonna be grinding sometimes. What about this? Let me see if you guys can handle this. All right, what if, let me do this. you guys can figure this out. All right, you know one thing for damn sure. The answer has to look something like what?
Negative size.
No negative, right?
Or,
Or, yeah, did it look like a negative?
no.
So it's got to look like sine 2x, but why do you know this can't be it? Because what is the derivative of sine 2x? 2 cosine 2x, right? Chain rule? Is there a 2 out here? So what must have been here then to kill the 2 that comes out? A 1/2. Holy shit. You guys see that? So it's all a part of it. This is almost, this is really weird to think, because it feels like you're doing more than you should be allowed to, but I know the answer must look like this fundamentally. Yes? That's the only way to take a derivative and get this. But if I take a derivative of this, I get a 2 that isn't here. So what must have been here to kill the 2? A freaking 1/2, right? You guys okay with it? No? Are you okay with cosine 2x had to come from sine 2x? And that's really the same thought process here. But if I take a derivative of this, wouldn't chain rule make a 2 show up? So then what must have been here, since there is no 2 there must have been a 1/2. Because now what happens? We take this guy's 1/2 cosine 2x times 2, the 1/2 kills the 2, and that's exactly what we got. So it's sort of like, one thing you guys sometimes do is this angle cannot change as you're doing derivatives. It can only change if you apply an identity or something, right? And a derivative can't change the inside of the function. That's basically what chain rule kind of, it leaves the inside the same and the inside gets a turn, right? Let's see. Oh, what about, what about this? Well, let's start off easy. Now, this is going to be interesting. Yes? Yes. I totally accept that answer. There's one thing I have to add in here. And let's talk about why. This is not quite right, but it's beautiful right now. There's a weird little side note. Can anybody do a quick air graph of 1/x? Anybody? You have to use 2 hands, believe it or not, because, right, doesn't it look like that? It's the most basic I love it. Everybody's going. It's like you're orchestrating. This then, the domain of this is this, isn't it? The only number I can't use is 0. Does this domain match up with that? What's the domain of natural log of x? 0 to infinity. So taking a derivative can't fundamentally change a domain like that. It can alter a little bit, but it can't fundamentally, or not taking a derivative, but answer. Yes?
Yeah, it kind of did. It took away all negative infinity, didn't it? Did it just take away all of like
It took away half. Can't really cut infinity in half. But here's how we cover our ass. It's actually this. That's the general rule. Now, why didn't that show up before? Because we were given natural log of x with no absolute value. Its derivative would still be 1/x, just the domain would have to be 0 to infinity, right? Okay, maybe. That's a little weird, I agree. But you can see, I can't, this guy can handle -3. This guy needs to also be able to handle -3, can it? Yes. Okay, maybe. So I'll show you where that's kind of important to kind of remember. So can you do this? Don't overthink it.
Natural log x plus 7, or absolute value of x plus 7.
Yeah, natural log, absolute value, x plus 7. Why do you not have to worry about, don't forget, taking care of anything, what's the slope of this?
1.
also known as the derivative, right? So there's no, if I take this guy's derivative, there's no shit that would come out. Yes? Okay. Let me stop for a minute. Okay. Let's see what else I want to do. Oh yeah, real quick. One more little thing about, what about if I had secant squared of 3x? Again, you're doing anti-derivatives. So what would I take the derivative of? So it ends up there. Tangent. And then what's the one? So you know it's got to be this. You know it has to be this. But there's something, not just the plus sigma. There's something missing because the derivative of that would have what out front?
1/3.
Well, the derivative of that would have a 3 out front. So you better put a 1/3 to kill that. And again, I really want you guys to understand. We are piecing together what the function was that we took the derivative of. Yes? I know it's got to have this fundamentally. But this guy's derivative, chain rule, would have put a 3 there. So what must have been in front of this guy so that no 3 would show up? Freaking 1/3, right? You guys see that? So this feels a little bit like we're cheating, but we're totally not. We are constructing what the original function must have been. So its derivative ends up where we were. So we're kind of allowed to construct it. So we can put what we need there. Because we don't know what the freaking function was, so we have to kind of do it step by step. Is that right? So I know this can feel weird, like, why are we allowed just to throw 1/3? Because we know it had to be there. We know it did. Okay.
Oh, okay, let's see.
You can't just put a 7 there, right? Because that wouldn't be this. You have to put a 1/3 there. So I didn't choose 1/3. I know it had to be there to kill the 3. Yes?
Yeah, so you like an 8 was there, you put 1/8.
Beautiful,
9 was there,
right?
1/9.
Whatever chain rule makes happen, I can undo a constant. Now, here's a weird question. Let me just tell you right now, we can't do this. And I want somebody to tell me why we're not able to do this yet. If I give you f of x is sine of x cubed plus x minus 1. What would I have taken the derivative of to get here?
Maybe plus sign and then it'd be
You
3x.
can't do it. I love that you guys are trying, even though I just told you we can't. So why can't we? Now, real quick, what if I had this function given to me? Can you guys do the derivative of this? It'd be sine of shit times.
X squared plus 1.
So what is missing here? What is missing here to be able to do this? Isn't this missing? So it's not a constant missing. If a constant's missing, I can kind of adjust the constant all day long. Because that's fine. Constants aren't directly affected by derivatives. But if it's a variable expression that the chain rule requires and we don't got it, we can't do it. At least not yet. Right? Calc 2 is first all about learning more and more and more methods to do this. Yes?
Why couldn't you just do like 1/3x squared plus 1?
Because, all right, let's do that. I love it. Kick ass. Ricardo's like, that's full of shit, Jeff. No, you didn't say that. What if I had put this? Sort of like we did with constants, right? This is a beautiful, so you're like, it's this, Jeff. Screw you, I didn't even forget my plus c, so leave me alone, right? If you take this guy's derivative, will it be as simple as this? Wouldn't you have to use quotient rule? Wouldn't they have a lot of shit going on? So why am I allowed to do this? Because what's 1/3's derivative? 0. It doesn't mess my derivatives up. That's why constants, I don't give a shit about constants. I can make them work. I can do stuff like that and make them work. But if I am missing a variable expression, I am screwed. This does not work. Its derivative would be way grosser than this, right? So there's no way that's the answer. I really want you to understand, I don't give a shit. Constants don't mess. I gotta get the constant right, but they do not mess me up at all. So, for example, what's the derivative of x squared? 2x. What's the derivative of 7x squared? 14x. Was that any harder than that? Well, it's just a stupid constant, right? But if I say what's the derivative of x squared, you say 2x, and then I say what's the derivative of x squared times natural log of x? Is that harder? Shit, yeah. Right? So constants don't matter really. They have to be correct, don't get me wrong, but they don't do anything to the fundamental calculus we're doing. They just kind of come for the ride. That's why I'm allowed to do this all day long, but this ain't never gonna work. Because now to check it, oh, flip. I almost said fudge, right? Right, you guys? The Queen Mother Mary of all hammers. Oh, fudge. All right. You guys kind of get a feel for this? There's a whole method we'll learn in 5.5 for when the inside is more than just a constant on. So there's a whole method we could try. But I wouldn't be able to do it if I didn't have the 3x squared plus 1 to work with. Okay. Let's see. Okay. Oh, all right. I keep forgetting to do a certain kind of problem. So what if they gave us what if they gave us what do you got? 3 sine 2x, right? And they told us f of pi is -2. So did they give me more information than we've gotten so far? They being me, right? Okay. And then, so how would I, first off, what would f, big ass f of x? Can somebody tease that out for me? What would that be? Yeah, you know it's got to, so I focus on this, right? You know it's got to be cosine 2x, right? Negative, yes. And now you piece together what would have to be out front. 3 halves. The over 2 would kill the 2 that comes out of here, right? Plus c. What does that extra piece of information do for me? What am I able to determine now?
Plug in pi.
Plug in pi and I can figure out what
When it equals -2.
c is. So I didn't just tell you, again, this tells me the slope of this, yes? Are you guys cool with the fact there's no prime here? But that is the slope of this, because this is the anti-slope of that, and it's not really the right phrase, but, right? So in general, f of x is equal to f prime of x. This is, do you guys understand? If that's the antiderivative of, that's the antiderivative of this, this must be the derivative of that, right? Yeah, okay. A little side note. Since I told, so this tells me the shape of this. This tells me where it is. So now I can get a specific constant related to like the y-intercept or whatever, right? So what is f of pi? It's going to be -3/2 cosine of 2 pi plus c, and that's supposed to equal -2, right? So now I can solve that for c, right? So again, f by itself tells me the shape of big ass F. Without more information, I don't know where it is. I did give us more information. Now we can figure out where the shit it is. So what is cosine of 2 pi? 1. Right? Check my work. Now you don't circle that. What's the answer?
-3/2 cosine 2 pi plus.
Yeah, the answer's got to be this, but I can throw what c is. So the answer is big S f of x is specifically this function. Yeah. So it is the function whose derivative is this, but that goes through that point also, right? So it's a specific function now. Okay. By the way, when we put the plus c down, or here, I've created what's called a family of functions. Right? So it's not, you don't go use the family, whatever you want to say. Family of functions. And if I give you more information, you're actually getting the specific, the nephew, or whatever the shit, right? The member of the family that does this. Is that cool? The family thing is not my word. It's actually the word mathematicians use, right? The nephew thing was definitely my word. I always love it when I hear family. I'm like, so who's that? It's the great uncle. Or Grunkle Stan. Okay. I think that's all we need to say about. Yes, I love it. On page 352, they kind of list functions and they show their antiderivatives. What about, I didn't do this yet. What about, can anyone tell me what the best function that's not a polynomial to take the derivative of? Any function that's its own derivative?
Oh, e of x.
E to the x. So if I said f of x is e to the x, what is big S f of x?
E to the x plus c.
There it is, big S. All right. Easy shit. All right. What if I said? Oh, by the way, let me do this. What if I said g of x is e to the x? So it's big S g of x. So no matter what the letter is, that's the relationship, right? Oh, sorry. Jeff, make a different problem. There we go.
So you got 1/2.
Yes. So it's got to be e to the 2x because it's its own derivative.
Oh, yeah.
But a 2 would try to come here. So there must have been a 1/2.
Plus c.
Okay. And again, why does it make sense that antiderivative is going to have this unknown thing? Because when we take a derivative, we lose information about the constants that were there. So of course, going backwards, I'm like, could have been anything there because we lost that information, right? That's why they have to tell me more information to figure out what the shit this was. Okay, like. Okay, I think that's good. Yes. Don't worry about hyperbolic stuff, right? Okay. All right. So last thing for today. Well, actually, let me see. Yeah, let's do this. Maybe I won't get into 5 yet. I've got this thing. On one side, it's got stuff about chapter 5. Don't do that side with all the neat graphs. Do the other boring side. The one without the neat graphs. Yes.
Oh my gosh, I
Oh.
saw that too. I was like,
Yeah, okay. I saw people staring at it. I'm like, I don't know what I did. So yeah, I just
Okay.
left off my -2. So what should it be?
Negative 1/2?
Yeah. So
Okay.
it wasn't some weird part of the process. It was just me forgetting it was a negative. Oh, I see what happened. The glare is right there. So I totally didn't even see. I even forgot what I said. Okay. Yeah. Just another showcase that I am a human. All right, so we got a few minutes left. I want you guys to try out these problems. And real quick, what do you think you do on C and D first? What do you think what you do with them first? What do you do with derivatives when I give you a function? What do you do with it first? I gave 2 to you. Pardon, did I? There we go.
You did.
I'm sorry.
I'm so sorry.
She's all like, what did I do to this guy? Again, so look at C and D. What do you think I do with them first?
Simplify.
Simplify. I love it. So derivatives, antiderivatives, what do you do with the functions they give you? If you can simplify them, you do. Okay. Oh, I think we did exactly this, almost exactly this one. Oh, well. guys see that blue marker? All right. This first one, I know this is relatively new to us, but it should have been an easy one because that 5 basically just goes back up, right? And if you use the rule 5 and you would divide by 5, so cancel, so x to the 5th,
Plus C. Minus C?
is it a minus 3x? Is that cool? And I think we almost did exactly this one earlier. What's this guy?
Natural log of absolute value, that's what it
Yes.
is. Plus C.
Yes. I remember the first quiz I did on this as a student, I didn't put any plus C's. And the professor just wrote this giant plus C. Oh. Who got this one simplified?
I just had it.
Tangent, sine, theta, over cosine theta, right? Secant theta is 1 over cosine. So what happens to the over cosines?
Cancel out.
Cancel. Look at that shit. So what is big ass F of theta? Man, Blue, you were dying. Poor Blue.
Cosine theta plus C.
Here, what is it now?
Wait.
If it's cosine, what's your
Negative
cosine? Yeah, negative cosine.
Plus C.
How are we doing so far, you guys? Is that pretty good? What's up? That one was hard? Yeah, this one you just gotta remember, taking it to sines and cosines is especially because there's no squares. When I see squares with trig, I think identities. When I don't see any squares, I don't necessarily think identity, I think sine, cosine. And then there I did some work, right? We don't know how to anti-differentiate a product. In fact, there isn't really a product rule for antiderivatives. There's an answer to the product rule, which is weird. In fact, part of that you learn in Calc 2 if you take Calc 2. So what I did, a lot like what we had to do before we learned product rule, we had to multiply shit out, right? Multiply shit out. Now big ass F. This one's nice, right?
X to 6.
6 basically goes back up.
Plus
That would be x to the 4th.
9.
Good, 9.
Plus 27.
Good. This would be x squared. Cut that in half.
Plus C.
Yes. Okay. Of course, this one's direct, pretty direct, except for the 3, right? But we all know what to do with that now.
1/3.
Say again.
1/3.
1/3.
Tangent.
Tangent.
3x.
3x. Plus C. I was thinking about those old commercials. Expedia.com. That's just me. Plus C. All right. And then this guy starts off easy. Yes? Anybody agree with me? Big ass F would be sine x plus C. But I tell you that plugging a pi over 6 in gives me 1. So what is sine of pi over 6? 1/2. So of course C is 1/2. So then your answer is, yes, your answer has got to be big ass F. We're going to sine x plus 1/2. Shabba. Not too bad, right? Again, the more you know your derivatives, the easier this kind of thing's going to be. Now, what's really weird is, so this is the end of chapter 4, which makes sense. After you've done all the derivatives, we talk about doing the opposite of derivatives. Chapter 5, let me see. Yeah, I got it. I'm going to do one more thing. I'm like Columbo. One more thing. No, is that too old of a reference? Probably. Look it up, kids. It's actually, you can do it, Jeff. There you go. show you one kick-ass thing. So that's 4.9, antiderivatives. Chapter 5 starts off seemingly talking about something completely unrelated. Seemingly. Chapter 5 says, what if I'm given a function, in this case sine, right? Can I make this? Yeah, I can't. Let me turn you off. No, I want to turn you off. Oh, well, too bad. Let me do this. There, okay. So here's the sine, right? And what chapter 5 starts off, it seems like it's unrelated to this. Eventually we're going to prove it is directly related to antiderivatives, but we don't know that yet. Chapter 5, section 5.1 starts off with, I'm given this function. What if I want to know the area under the function from 0 to 2?
Why would we want to know that?
Because, think about this. If I know, for example, a velocity function, and let's say this is miles and this is hours, so velocity is miles per hour, right? If I find the area under that, that would represent the position I'm at. That would be the accumulation of all the changes in position, so it will tell me where I end up. So finding the area under a function directly relates to undoing a rate of change. I don't know if this makes sense. So if I have a, let me say this better. If this was a velocity function, this would be miles per hour, for example, right? This is velocity, and this would be hours. Wouldn't the area be miles per hour times hours? Wouldn't that give you miles then? So if I have a variable velocity, is it really easy to calculate over so much time where I end up? No. If I had a constant velocity, easy. If I have a changing velocity, much more difficult. So if I have a way to figure out the area under the curve I'm given, there, that's the position. So what could I do with that with? Any rate of change anywhere. I could do the same thing. Flow rate of water through a certain place, I could figure out how many gallons of water after so much time, right? Or flow rate of oil out of a boat, out of a Exxon Valdez, for example. And I want to know if we can't get it done, if we can't get it patched after so many hours, how much oil will leak out? I have to do this shit because I know the flow rate. And is the flow rate constant? No. Are you guys kind of with me? So it's a really good question, Thomas. I love it. Please ask that kind of question. You don't have to be like, why did we do this shit? But you work, which is good. But it's always a good question about, why the shit would we do? No, again, you didn't do that. Why would we do this? Okay, real quick.
I think the correct answer was I'm going to assume Aristotle because that's what popped in my head. He said, you know what? I don't like teenagers. I'm going to make them do this in the future.
Yeah, that's exactly. Now, do we have an equation from geometry that would tell me the area of this shape? No, right? No, we do not. What do I do? Just enough time to do this. And I know you guys disagree, and I don't care. I don't think I showed you this. This is so kick-ass. Let me see if I can do this really quickly. Do you know why the area of a circle is pi r squared? I didn't show you this, did I? Do you know? Does anyone know? Okay, now watch this. This is so freaking cool. If I slice down the middle, right? Make little okay, baby, no, okay. If I slice down the middle and then I cut from the center, but I don't cut through the edge. Are you with me? So I'm going to open this up. So if I cut like that, make some triangles. So I don't cut through here, but I cut all the way through there, and I pick it up and do this. Can you guys see that happening? When it become like this? How many triangles? Just put some triangles in, right? Right? Okay. What do you think I'm going to do to the bottom piece? Same thing. Chop it up. Open it up. Fit it in. What shape do I have there basically? In fact, if I make the triangle smaller and smaller and smaller, it's going to become more and more and more what shape? Rectangle. Does anyone know how long this is? Which would be this.
Hi.
No, I didn't say tell you what the radius is. What's all the way around? Circumference is 2 pi r. So what's halfway around?
R.
Pi r. This is pi r. And how tall is this? Or that's right. So what's the area of the rectangle? Pi r freaking squared, right? Now some of you guys could argue it's not perfectly a rectangle, but like I said, if I cut this really, really, really tiny triangles, it'll become basically a rectangle. So this is like a limiting process, yes? The limits are coming back. Oh yes. Exciting. So watch this. This is simple. This is truly the last thing, right? You're all like, I don't believe you. I don't blame you. Yes. So any shape now. Watch this. Let's see if this makes sense. If I use one big ass rectangle, and the idea here is the height of the rectangle could be either related to the function here or the function at the other side. So I made it so it's equal to the function at this side, right? Is the area of that rectangle close to the area under the blue curve?
No.
Not really, right? Why? Because there's just a little sliver that I don't, and then there's a huge freaking amount that I do count, yes? How could I make this better?
Adding more.
Add in more rectangles, the same way I added more triangles, right? Let's do 2 triangles. Oh, jeez, Jeff.
Yeah, they.
Good Lord, this thing is touching.
Yeah, it goes from 1 to 200.
I know.
You
I did that on purpose, but now I can't. Oh, okay.
could.
So now the height of the triangle, that's a little bit better, but it's still pretty bad, yes?
Yeah.
So now this rectangle is based on the height here, and this one's based on the height there. I cut it perfectly in half. So of course, to make this really good, and let me show you, the actual answer is this. Don't worry about these symbols yet. The actual answer is this, and as I increase my n, you see how I keep fitting more and more rectangles?
Yeah.
Isn't that much better now? Doesn't that look perfect now? Look how close this is. This, don't worry, again, the symbols we're going to talk about. This basically, that big ass Greek letter S means the sum of all the rectangles, areas, is really close to the actual area under the curve. If I zoom in, you can still see, it looks like a dinosaur background. Stegosaurus.
It's Godzilla.
You can see all the little rectangles. They're I wish they would draw in the actual rectangle, but there's a thin strip of a rectangle right there, right? And then a thin strip next to it, and a thin strip next to it. So the bigger n is, the bigger the number of rectangles, the better the resolution, the better the approximation. Oh shit. We're gonna be doing that by hand. Oh yes. Oh, I love having Mr. Wolf. We're gonna be doing that by hand. We're not gonna do it a lot. You guys remember before we knew derivatives, shortcuts, we had to use what? The limit definition derivative, remember that? We're gonna use this for less time than we did that before we get shortcuts.
Oh,
Right?
okay.
So you just gotta, remember, light at the end of the tunnel. There's gonna be a lot of nifty by hand stuff. That's plenty for today. So don't forget, bring this back next time, because we'll do the other side next time, the sheet. Okay.